I have 0 over 0 or infinity over infinity, I have an excellent tool called L'Hopital. You always have to make sure that it's L'Hopital ready before you just go taking the derivative. So if I plug in 0, cosine of 0 is 1. Cosine of 0 is 1. That gives me 0 over 0. Okay, it is L'Hopital ready. So L'Hopital is not quotient rule. So I'm going to take the derivative of the numerator. So it's negative sine of mx, doing chain rule, times m. And then taking the derivative of negative cosine, I get a plus sine nx times an n all over 2x. Now if I plug in 0, you know sine of 0 is 0. So this would give me 0, and this would give me 0, and I get another 0 down here. It is necessary to do L'Hopitals again. So as long as you have this or this form, you do L'Hopitals. I'm going to carry the negative m along. Take the derivative of sine, that's cosine, of mx times another m, and then taking the derivative here, I'm going to carry the n along, take the derivative of sine, I get cosine of nx times another n all over a 2. Now when I plug in x equals 0, cosine of 0 is 1, so I get negative m squared, cosine of 0 is 1, plus an n squared all over a 2. So notice I am writing limit. Now I don't write limit, right? So it is necessary to write limit every time. I take points off for not writing it. And some people are in the bad habit of saying limit as x goes to 0 and then just putting an equal sign like that. Whoops. This is incorrect also. I would take a point off for that, because you can't say limit and there's nothing there. So make sure you're writing it up correctly. All right, let's go to the next one. So if I plug in x equal infinity, notice the limit can go to anything. We're just plugging it in to see if I get infinity over infinity or 0 over 0. So here I do get infinity over infinity, because you know e to the infinity is infinity. So then if I take the derivative, I get 3x squared over e to the x over 3 times a 1/3, doing chain rule. This is still infinity over infinity. I'm going to take this and put it outside the limit. It's just times 3. And now I'm going to do the L'Hopital's rule on this, right? So I get 6x over e to the x over 3 times another 1/3. So then I can say, oh, I know that this 1/3 will come outside. So it'll be a 9, carry the limit. And so, oh, wait a second, I forgot to check. I'm plugging in infinity, right? Do I still have infinity over infinity? I always have to check. Here I saw that I did have infinity over infinity, right? This is infinity over infinity. Do I have infinity over infinity? Yes, and you don't have to write it, but you need to check it. It is infinity over infinity still. So I do it again, limit as x goes towards 0. So this 1/3 comes up, so I get a 9. I can put it outside or keep it inside. Take the derivative, 6 over e to the x over, sorry, that's really messy, e to the x over 3 times another 1/3. And now oh gosh, I didn't, so that's another thing I was going to warn you about, is that it's really easy to change what the limit is by mistake, right? So limit as x goes to infinity. Now I finally get a number over infinity, so the answer is 0. Let's look at this. So you have to know that inverse sine of 0 is 0, because that's the angle you can take the sine of to get 0. So I get 0 over 0. So let's take the limit. So I get 1 over, and then you know the derivative. So let me write it down here just to remind you. The derivative of arc sine. I'll just use the u because we know we have to do chain rule. 1 over 1 minus u squared times the derivative of u. Okay, I'm going to have 1 over square root of 1 minus 3x all squared times the derivative of 3x, which is 3. So I see I've got a fraction, I have a 1 in the numerator, and I've got this fraction in the denominator. So let's multiply by the reciprocal. So I would get root 1 minus, and I'm going to square this guy out, so I get 9x squared, and then that's all over a 3. Now plug in x equals 0, I get 1/3.